Today, I want to cover a very interesting median LeetCode question named longest palindromic substring. In this question, you are given a string S, and as the title says, you need to return the longest palindromic substring. If there are multiple candidates, you are allowed to return any of them, despite the fact that it was not called out in the problem description. From the constraints, we know that there are at most 1,000 characters, and each character is either a digit or a letter. This question is interesting because I used to only know an n to the square solution. But recently, from Wikipedia, I not only learned the ON solution, but also helped improve its implementation, so that the solution is now more readable and understandable to everyone. In this section, I'm going to first cover the ON square solution and talk about which computations could be saved, resulting in a better ON solution. For the ON square solution, I'm going to call it center expansion solution. If we are given an example of A, B, A, B, C, B, A, B, C, for each palindrome that has its center at a character, I would like to expand its radius as far as I can. For example, for the first character A, I will first use it as a center and try to expand its radius. However, since there's nothing on its left, its radius is just 0 as itself. It's the same thing for the B. For this one, I know that I can try to expand it to the left by 1 radius. How about the next character? We have BAB here. The next one is just B itself. Next one will be BABC, BAB, and then followed by B itself, and then CBABC, B, and then C. So far, we talked about how we can find out the palindrome center at the character. Now, how about the palindromes that are not centered at the character? For example, A, B, B, A. The center is between the character. The one trick to deal with this case is to introduce a dummy character like underscore. What we'll get is A underscore B underscore B underscore A. This is guaranteed that this is odd length because it's centered at this underscore character. So we can apply the same strategy as we mentioned before. Now let's think about the complexity of the algorithm. We will need to enumerate the center of the index in range n, where n is the length of the given string. From the center, we need to do expansion. We need to expand the radius. And as you can imagine, the radius is at most n. Eventually, the complexity is n centers times the maximum radius we can find, which is n. So this is ON square solution. Now let's see how we can save the repeated calculations. The algorithm I'm going to cover next is called Manacher's algorithm. Manacher's algorithm. Previously, we need to calculate radius independently at each position. But now we would like to reuse the radius results as much as we can in order to get an amortized ON solution. The radius, by definition, is the length you can extend to the left or to the right, excluding yourself. So the results for this A will be 0, will be 1, and then this one will be 1, this one will be 0, and this one will be 3. And assuming that we are now at this position. There's another thing I want to maintain, it's called mixed radius. For example, if now I move on to this B location, if I want to reuse the results from the previous palindrome, the mixed radius that are covered is these 2 characters. So this guy is 2. Now we're going to talk about the first case, case A. From the previous palindrome results, we know that this B is mirrored here, which is this one. In the first case, we can first find out the mirrored character, and then since its radius is 0, it's smaller than mixed radius. So the mirrored radius is smaller than max radius. This is the first case. When this happens, we know that the radius for this current position, B, should be assigned to the mirrored radius. It is because it is already calculated, and we know they are mapping to each other, so we don't need to do any additional calculation. We can return the results directly for that position. Okay, if we move on to the next character, A, the max radius now is 1 because from BA, BC, BAB, we only know one more character information. And this A can also be mapped here. There's a mirrored version of it, and it's actually here. Now, let's think about the radius for this A. We know that the answer is 1. 1 equals to 1 here, right? So the second case is case B. The mirrored radius actually equals to mixed radius. When this happens, the radius, again, can be assigned to this guy, right? We know that they map to each other. So the radius should be the max radius. But is it possible that it can actually go beyond the previous calculated radius? It is possible. So we need to keep expanding. And in this case, in fact, if you keep expanding it, you will know that it can actually go beyond one more length. So this is the case B. We first assign the max radius to the current radius, so we kind of skip several steps potentially, but then we need to keep expanding from there. And lastly is the case C, which is when we move on to the next character B. This character B, we know that the max radius is 0 because we're already at the boundary of the previous calculated palindrome. This B can be mapped to here. And we know that the radius is 1, whereas the max radius here is 0. Mirrored radius is actually larger than the max radius. This is the third case. The radius is actually also the max radius. But different from the case B, we don't need to do expansion here. Why is that? The reason why we don't need to do expansion here is because if it could expand by 1, let's say there's a ABA or a CBC here, then this string in the middle, BABC, BAB, should have been extended longer. Since it is not expanded by one more length, we know that this B cannot go beyond further. This is a very key difference between case B and case C. All right, this summarizes 3 different cases mentioned in this Manacher's algorithm. And this is the minimal example I can find that covers all 3 cases in order. Now, you might be curious about the complexity. How can we make sure the complexity of this algorithm is O(n)? First, number of centers is the same, right? The number of centers is still O(n). But that doesn't guarantee that the overall algorithm is O(n), because we might still spend O(n) time in expanding the radius. If you take a closer look, you will know that the center of the index plus the radius is actually monotonic. If it's monotonic, the complexity is bounded by 2 times n, because this one is bounded by n. This guy is bounded by n. If the summation of these 2 values is monotonic across the whole algorithm, then you will know that this is O2n or O(n). This algorithm eventually runs in O(n). I hope this visualization helps you understand how the algorithm goes, and we'll cover more in the actual implementation. We'd like to start with adding the dummy character underscore into the given string. I will do extended s equals to underscore join list s. So this s will expand the given string into a list of characters, and then we'll join it by the underscore. After that, I would like to get the length of the extended string. Now, we'll start with the n-square algorithm. In the n-square algorithm, we'll first maintain the candidate info. So this is the info of a tuple. The first element will be the length. I will deploy it to 0, and then an empty string. We'll keep updating this best candidate info till the end so that we can return the best candidate we can find. Now we'll start iterating the center of the index in range n. The radius will be always default to 0, and there will be a while loop with multiple conditions. The first condition we have is center minus radius plus 1 needs to be larger than 0. And the center plus radius plus 1 needs to be smaller than n. And lastly, the extended characters needs to be the same. So this one minus radius plus 1 needs to be the same as extended string plus radius plus 1. If all three conditions are satisfied, then we are safe to increase the radius by 1. At the end, we'd like to update the best candidate we have. It will be a max of the previously found best candidate info with the current one. So the current one will be a tuple of radius times 2 plus 1 and the string itself. So it will be extended as minus radius to center plus radius plus 1. Now, before we return the best candidate we found, we need to do some modification. I'll call this is the extended palindrome equals to best candidate info. And then before we return it, we'll need to join something by the empty space, and the something will be the extended p split by the underscore. And now let's see if it works. All right, it passes 2 cases. Now let's do submission here. All right, it passed around 50% of the users, and then the runtime is around 700 milliseconds. Now let's move on to the ON solution. For the ON solution, I would like to maintain the radius for each center. Default everything to 0. I also would like to introduce a character code anchored center index and default it to none. This is the center that we have the information and would like to reuse for the later computations. As usual, I will enumerate the center in range n. And there will be 2 conditions here. First, if the anchored center index exists, and we know that the current index is within the coverage of it, radius anchored index. If this happens, we know that we can reuse the information. Otherwise, it's unfortunate that we need to expand the radius ourselves. It will default radius to 0. Now let's take a closer look at what happened here. In this case, we'll first need to find out the mirrored center index. The way to find out is from the anchored center index minus the center index, the current center index minus anchored index. So this will help us find out the mirrored center index. After that, I also need to know the max radius. The max radius is just anchored center index plus its radius minus the center index. Now with these information, we can start with considering 3 different cases. And they are all about the relationship between the radius of the mirrored center index with the max radius. There will be 3 possible cases. It will be either smaller to, larger to, or they're the same. Now, in the first case, if the mirrored radius is smaller than the max radius, we know that it cannot go beyond that, right? Because it's bounded, it's covered in the max radius. We can assign the radius of this new center, the current center, equals to the radius of the mirrored center. And after doing that, we can just continue and move on to the next center index. How about the second case? We know that the radius is larger than the max radius. In this case, we also know that the radius at this new center index equals to the max radius because it's limited by the large palindrome. If you could extend beyond this point, then the anchor center palindrome should be able to extend further. In this case, we know that it's bounded by the max radius, and we can also continue here. Lastly is when the radius expanded to the boundary of the anchored palindrome. In this case, we can only know the minimum radius it has, but we don't know the upper bound of it. So we need to keep expanding the radius later. The radius will first be assigned to the max radius, but then we need to keep expanding it. So no matter it's because you are at the boundary or you have no information and need to stop over, we now have some radius initialized here. And we'll basically need to do the expansion as we have in the underscore solution. So the center index minus radius plus 1 needs to be larger than 0, and the center index plus radius plus y needs to be smaller than n. And eventually, extended as these locations need to be the same. That happens, we know that we can extend the radius. What? After early extension, we are now ready to assign the radius to the current index. It will be radius. At the same time, since this is a new expansion, I would like to keep the center index as the anchor center index, so that the future center index to be visited can reuse this information. This covers the Manacher's algorithm. I modified a little bit so that now I think it's more readable. Previously, there's a while loop inside another while loop, which is very confusing, but now I think this is more straightforward. At the end, I will need to, again, find out the best candidate by maximizing the following results. The radius times 2 plus 1. This is the same pair we found earlier. Extended as center index minus radius to center index plus radius plus 1. I need to do this for all the center index in enumerate. Again, after I found the best extended palindrome, I need to do some conversion. Here I will do the same thing. Return mstring.join extended b.split. Cool. So that's it. Let's see how it goes. Oh, oops! I need to hide this part and do a run. All right. So yeah, it passes all the cases. And let's do a submission now. Awesome. So you can see now it can beat around 97% of the users, and the runtime's 92. So previously the runtime is around 700 or 800, right? So that's a very significant speed up. And this concludes the ON solution we want to cover today. And thank you for watching.